Welcome to your Get That Nugget for GCSE Maths. Today we will be concentrating on giving you a framework to answer grade 4 style Laws of Indices questions. Please note this session is to complement your lessons with the teachers. It is not to replace them in any way. So let's have a little look at some examples and work through some questions all about index laws. Now, indices or index or powers is that little number that you might see above a letter or a larger number that we see in the top sort of corner sort of floating around. So there's a few of the basic fundamental index laws that we need to know. So for the purpose of this, we'll write a couple of those down so we've got them as a reference. Now, the first one, and you might see letters for this. So what we do is we can multiply numbers using indices. Now, I'm not trying to confuse matters with letters, but what I'm trying to say is when we multiply the powers, what we actually end up doing is we add them. So whatever these two numbers were, if we were going to multiply these, the easy rule is we would add them. And similarly, if we think about dividing powers, our index laws tells us that we subtract the power. So it'll be m and then minus n. The other rule we need to think about is raising a power by another power. And you tend to see this. So we want to raise that all by another power. So what you do, the rule for this one is we've done the add, we've done subtract. You guessed it. What you do is you multiply those two numbers together. And then the next fundamental rule effectively is that anything to the power of 0 is always 1. So that's a really important one to remember. Anything to the power of 0 is always 1. So some of the really key index laws there. If you multiply the powers, the rule is to add them. If you're dividing the powers, the rule is to subtract. And when you're raising a power by another power, you would multiply the powers. So let's then develop that a little bit further and have a little look at the sorts of questions that we might get. So we'll start with this question. So we can see here, what we're doing is we are multiplying those powers. So what we're doing is we are doing x to the power of 5 and we are multiplying it by x to the power of 2 or x squared. Now we've said the rule for multiplying powers is that we simply add them. So 5 plus 2 is going to give me 7. And it's that straightforward. If we look at the next one, I've got g to the power of 7 and I'm going to divide it by g cubed. Remember, a fraction is just the same as division. So we're looking to divide the powers there. If you think back to our earlier examples, we know the rule for dividing powers is we subtract them. So 7 take away 3 would leave me with g to the power of 4. Lovely. Nice, easy one marker, some of these questions. The next one we've got is we're raising a power to another power. And if we can remember back, raising power to a power means we multiply the powers. So 4 times 5 is going to give me f to the power of 20. And then this question says, write down the value of h to the power of 0. Well, we know anything to the power of 0 is 1. So the value of that is simply 1. So a couple of examples there that use the fundamentals of the base of the index laws. And again, multiply, add, divide, we subtract, power to power, multiply, and then anything to the power of 0 is going to be 1. So can we develop this a little bit further there? Nice single mark questions. What about when the questions might become a little bit tricky? Well, for this one, we've got 4 lots of x to the power of 5 multiplied by 2 lots of x to the power of 2. Now, this one tends to get people a little bit because they're a bit like, oh, I've got numbers involved. Well, there isn't a rule for multiplying numbers. We just multiply the numbers. So in effect, I'm going to do 4 times 2, which is going to give me 8. So I've dealt with my coefficients, the numbers in front. And then I know that when I multiply powers, I just need to add them. That's the rule. So it's x. And then when we do 5 plus 2, that's x to the power of 7. So in effect, we just deal with those almost as two separate areas. We do the numbers first, and then we'll add the powers. Let's explore a little bit further with a fraction, which again, as we've mentioned before, is the same as division. So I've got 6 lots of g to the power of 7, and we're going to divide that by 3 lots of g cubed. Well, similar to before, what's 6 divided by 3? This doesn't change. There's no quick rule for this. It's just 6 divided by 3, which is going to give me 2. And then we know the rule for division, because this is just division, is that we subtract the powers. 7 take away 3 is going to give me 4. So it's 2g to the power of 4. This is probably the one I see the most where errors occur. Because what we've got here is we want to raise all of that to the power of 3. Now, the reason it becomes a little bit tricky is I need to raise the 2 to the power of 3 as well. So if I do this underneath, just so it's nice and clear. So what I effectively need to do is 2 cubed. Now remember, when you cube a number, you multiply by itself 3 times. So that's going to be 2 times 2, which is 4, times 2, which is 8. So the coefficient, the number in front here, needs to be an 8, because again, there's no rule. We just raise the 2 to the power of 3. And then we do know the rule for indices when we're raising a power is that we multiply these two numbers. 4 times 3 is going to be 12. So the full answer is 8 f to the power of 12. You tend to see people forget to raise the 2 to the power of 3, but we must raise all of the thing in the bracket. And then I've chosen a slightly trickier one just to develop a bit further. We've got 5m squared n to the power of 5 multiplied by 2 m to the power of 4 and then n. Again, deal with the coefficients, deal with those numbers. 5 times 2, not a trick, that is 10. Then we can look at our index, our indices. We want to look at the ones that are similar in that the base is the same. This number or letter, whatever that is, they are the same. We can combine those. So here I've got m squared and I'm multiplying it by m to the power of 4. So I know the rule for multiplication is we can add the powers. 2 plus 4 is going to give me 6. And then when we might do a little bit of slip up is this one. I've got n to the power of 5 multiplied by n. Now, although there isn't a power here, we've got an n, which means there is a 1 that we don't write because we just assume the power's there. So I've got 5 lots, n to the power of 5, and I want to effectively add an extra n. So this becomes n to the power of 6. So where there isn't a number, sometimes it's nice to write the 1 out just so it helps you with the calculation, but there is always an invisible 1, we just don't tend to write it. So that's how we would do that question. And then in terms of developing this a bit further, what we'll see is I've got slight variation of how these questions might be asked, just so that we're not too confused. So here we are told x to the power of 5 multiplied by x to the power of something is x to the power of 12. Well, we know that you add the powers if you're multiplying. So effectively what that's saying is 5 plus this power gives me an answer of 12. Well, what do I add to 5 to get 12? Well, that's the same as doing 12 subtract 5. So my missing power, my question mark, has got to be 7, because 5 plus 7 would give me the power of 12. And similarly, I've done the same thing here. We've got g to the power of something, all raised to the power of 5 is g to the power of 15. Well, we know that when you raise a power to a power, you multiply. So effectively what we're saying is there is my question mark multiplied by my 5 has to give me a power of 15. Well, how many 5s are in 15? Lovely. The question mark has to be 3, because 3 times 5 would give me 15. And then I've just popped this one in here because there might be more than one stage to the simplifying. So what we've got is I've got g to the power of 3 multiplied by g to the power of 5 all over g. Again, do this in 2 stages because often this is a 2-mark question. So pick up the nice easy mark first. And that is obtained by our rule for multiplication, which all we need to do is add the 2 powers. So 3 plus 5 is going to give me g to the power of 8. And that's all going to be divided by g. Now, if we think back to the earlier question, where there isn't a power, we have to imagine there's just a 1 that we don't need to write down that we can't see. So in effect, what I've got here is I've got g to the power of 8 divided by g to the power of 1. Well, the rule for division is we subtract the powers. So that's going to give me g. 8 minus 1, or 8 subtract 1, is going to give me g to the power of 7. So that's there because it can be done in stages. Take one step at a time, and then just remember if there's no power next to that letter, that base letter, there's always that invisible 1 that we can't see. So there's a few examples of indices laws. Multiply, add the powers, divide, subtract. Anything to the power of 0 is always going to be 1. So with that in mind, I'll leave a few questions for you to go ahead and try. There's about, how many, 7 questions we've got there that utilise those index rules you've just looked at. So have a look through those, work through those and see how you get on.